So, number one says an experiment is conducted to investigate the effect of a magnet on a solenoid. The magnet is pushed towards the solenoid and the meter connected to it shows a deflection to the right. What is the polarity of the pole facing the solenoid? Because this was part of your homework, I want answers in the chat. Please write your answers in the chat right now. Please hurry up, hurry. Okay, I'm waiting for the answer. Number one, what was the answer? It was part of your homework. So what is the polarity of that pole? More. Okay, Hope Rose. Okay, let me unmute you. Must hope what's it called? Let me unmute. Where is unmute? I go. Was it wrong, Hope? Because let me see. Bulela. Super quiet. Ngala mo chatting. Ngala mo chatting. I so chat like ngala mo guy. Just right there mo chatting. Kasi mo answer. Because pala kuri, what is the polarity wa ngwana? Nainaki 600 ne. Are non-polar killing him all side. Okay, anyone, what is the polarity of that end? Polarity, please. Okay, what is this? Language. Hope it's stress. Aibo, why is Molami the only one who's answering? What is the polarity of that pole? Okay, we are many now. Okay. What is the polarity? I'm here. 1 and 1. Number one. What is the polarity of the pole facing the solenoid? I won't continue unless you guys are writing the answers in the chat, because this was part of your homework. So I'm trying to be sure if any of you have written what is the polarity of that pole. Aibo. No one is answering. Nothing. Study. What is the polarity? Michelle has written something. Okay. The message is okay. Someone said non-polar, someone said polar. Now please do not confuse the two. If you are being asked the polarity, let me do this. Let me write the camera. Don't laugh because you guys yo guys, I don't know how to switch this. I was supposed to press here. Okay, I'm going to switch cameras. Okay, aha. Muthatitwane. So, if you're being asked the polarity of uh, the end of a magnet, what we are simply asking you, is the pole a north or a south? Is it a north pole or a south pole? That is the polarity that we are asking here. Now I'm going to do this question only, then you guys are going to do number 3. So please don't ask me guys, I'm asking you. So if you are being asked about the polarity of the boundary, the first thing that you're going to apply is the right hand rule. So the right, are you guys hearing me? Huh? Okay. The right hand rule will help you to apply what you're being asked. This is our solenoid. I'm going to see. Let me see. Okay. This is the bar magnet approaching your coil. So they say that the deflection on your carbonic, and remember the first process, the deflection on the carbonic will show the direction of what? Of the current. Are we here? Okay. So the deflection of the current is awarded to the right of the left. Where? I'm asking, was the deflection to the left? To the right? I don't cool. Let me just go there. Okay, it is deflected to the right, right? So if it goes to the right, it will go to that part of the tree, right? So this simply means that the current will also move in this direction. I want you to understand this very much careful. So if the current is moving in this direction, right, I want you to apply the right hand rule on this coil, right? So if the current is moving down, this is our coil, right? So if the current is moving like this part of the coil will be what? Right? So if this becomes your north pole, this will become its south pole. And another principle says, if this part is the south pole, this also will be what? The south pole. And this will be the north pole. Therefore, the polarity of the bar magnet approaching the solenoid will be the southern pole. Are we clear? Any question? Do you have a question? Question, guys? Any questions so far? Hmm? Hmm. I have applied the principle of right hand rule, right? It says if this is part over here, right? Then because the displacement was to the right, this means that the current will move to the right in this direction. The way this change will move like this. So we are looking at the way on how the right hand rule over here, not on the power but on our coin. So the right hand rule is this on our coin, right? And we know that the current over here is moving like that, right? It's moving like this. This simply means that the sun will point in the direction of the North Pole. Remember, we are saying the right hand rule over here because this is the only place where you know the movement of the current. So if the sun points in the direction of the North Pole, it simply means that this part of the coin will be the northern part of the whole coin. If this is our north part, this will also be our southern part of this whole coin. If this is north, this is south. And then when we look at our magnet, the principle says if this part is the southern pole, it will cause or induce a south pole on the part of the magnet that is approaching that coin. Let me give you another example. If you are told that this is the north, this is the south pole, this simply means that this end of the coin will be what? Will be your north pole. Because this magnet is approaching the north pole of the magnet is approaching this coin. It will make the end of this coin that is near it what? North. Are we there? So I want you to answer question number 3. I want you to answer question number 3 is like right now. I'm giving you 3 minutes to answer number 3. I want the answer on the chart. 3 minutes maximum. Please hurry up. Let's hurry up. Number 3 says bar magnets moved out of the coin as shown below. Let me just zoom this. Number 1, which one of the following correctly describe the direction of the current and the polarity of the left end of the coin? When they say the left end of the coin, we are simply meaning this part over here. This part over here. What is what? What is the polarity of the left end? What is the polarity of this point? Is it a north or a south pole? And is the current moving from X to Y, or is it moving from Y to X? 12, 17, I want to see answers in the chat. Please hurry up. Just write this number A, number B, number C, number D in the chat. I want to see your answers. We have that document. Please. Hurry up, everyone. In the meantime, Ije Milky Bar, Okurito Limposin, Itajam, Y to X, north, Y to X, north. Which option is it, Mafona? Is it number A, number B, number C? Remember the multiple choice question. Y to X, north. Let me go. Y to X, north. Oh gosh. Y to X, north. Y to X, north. Number C, Mafona, number C. Okay, let me see. What is it? Number C, mobile. Hope number A, hurry up. Tavi, which option is it? Is it number A, number B, number C? Hurry up. Number B, okay. 1, 2, 3, 4. 2 left or 1 left? Who hasn't answered yet? Yes, Tavi. We are 6. Someone answered yet. Let's see who isn't answered yet. Ben 10, we want your answer. Amogelo. Kamogelo has answered, I guess. Nakisimo. Who is Mazal? Okay, whatever Mazal. Okay, fine. Okay, Benton number C. Unfortunately, all of you are incorrect. Mafuna, you are correct when you are saying it is from let me go back to the question so that we will be able to understand it. Number 1. If this is the North Pole, right, Mafuna, you were linking with just one thing. If this, let me show you something. If this is the North Pole, this simply means that this part over here will be what? Your South Pole. So if this is the South Pole, it simply means that the end of the left end, this part will also be what? South. You see, not north, because north is here. Remember, this magnet has been pulled out of what? Out of your coil. So it simply means that the end of the polarity of the left end of the coil will be what? South. This means that number A is out and also number C is out. Okay. So let's look at the direction. Right? If we are going to apply the right hand rule, someone got it correct. Yes, someone got it correct, I think. So this simply means that if this becomes the southern part of your what? Of your coil, someone got it correct, number B, I think. Therefore, here is your North Pole. So if this is your North Pole, it simply means that if you're going to apply the right hand rule, the curling of your fingers will be in this direction. Do we in which direction? No. Someone got it incorrect, man. The answer I think should be number D. Because if it is going like that, it simply means it's going to X to Y. No, number B. Yes, number B. Yes, it will move from X to Y. Let me explain it. Then, if this is your North Pole, this will be your South Pole. And if this is your South Pole, this will be your North Pole. And when you apply the principle of the right hand rule, this will do what? It simply means that the current will move in that direction. It will move like this. That's going to be the arrow of your what? Of your the movement of the current. So if it moves like this, therefore it will move like this over here. Oh my God. But like I really beg to differ. Okay, is there anyone who Tabi, please explain your answer for us. Because the time is running out. I'll send another link. Tabi, unmute yourself and explain how you got the answer. Because I think for me, the correct answer would be number D. Okay, let me just, because he doesn't want to speak, let me illustrate on the board why my answer is this. Okay. This is our magnet. Let me draw it over here. This is north, this will be south, this will be what? North. Right? And as we apply our right-hand rule, if this is our point, the killing finger will point in the direction of the current. Right? So if the current is moving like this, it simply means over here it will move like this. Right? And also it will move like this. Because if this is a positive signal, this will be the negative terminal of the galvanometer, and this is the positive signal of the galvanometer. So if it is moving like that, it simply means that it is taking us in this direction. So it simply means that it went from Y to X, because the principle is current will move from a positive signal of the battery to a negative signal of the battery. So let's say if we have not put here and not put there, how does that be different from if this was on pole, then it would be on pole, then the right-hand rule will be applicable in this manner. So that the sun pointing in the direction of the north pole, and the changing finger will point in the direction of what? In the direction of your current. Therefore, this is what you can move. If it is like this, it simply means that the current is going what? Is going up in this manner. Wow. Right? Now, vai delle meta. Is okay. The best way to claim this, right? Let's go to your question paper, I guess. Yeah, question paper. Let's look at the first question. Okay, we've done the first question. Let me. Okay, let's look at number 1.8, number 2, right? Look at this part over here. If this is the North Pole, you know that this is also be your North Pole, right? So if this is your North Pole, this simply means that because current is going to move from this terminal, you write them nicely. Okay, actually let me just show you a simulation to make this thing very easy. This is going to be the last question regarding multiple choice. And just be patient. So look at your galvanometer over here. Can you see where is the reference voltage in yellow? Yes. So if this is our magnet, right? If we put our North Pole, did you see what happened? As the North Pole approaches, your galvanometer reading will go towards the negative part of your galvanometer. Let's swap. If it is a southern pole approaching, your galvanometer will go towards the positive terminal or the positive part of your galvanometer. Okay? So, if you are given the deflection on your question paper, say, if they say it is deflected to the right, you'll be able to know that the polarity of the end that is approaching is your what? Your southern pole. Are we fine? You, hello? Okay. So this simply means that if, as the southern pole approaches, deflection will go away, will go to the right. So let's then debate over here. If the southern pole approaches, right, deflection is going to be to the right. If the deflection is to the right, it simply means that let me remove this, let me remove this, let me remove this. I think it now makes sense. Oh, nonsense. Let me remove this, let me remove this. Physics dot. If the southern pole is approaching, right, the deflection will be way to the right. So if it deflect to the right, it simply means that it's going to move from the right or the positive part of your galvanometer. Where's my pen? Okay, there it is. I go. It will move from here to where? No, is to move like that. I go. If the southern part of the magnet is approaching, it simply means that it will move from where? From Y2 to X. I don't think I do have the memo for this, but I will check it and send you the video. Come on. Sithabeng sohle ra mm, okay.